All right, here are solutions to perfect problem 7 for Math 243. We're given a random sample of 80 SOU students classified as, so in a random sample of 80, so this right here is my value for n, 48 of these good-looking people had taken a stat class, so this is x, in other words, p hat is equal to 48 divided by 80. Which is 0.60. And I know that 48% of all people, so this is P naught, is 0.48. And what I want to do is figure out if I can draw a conclusion with 98% certainty. So this right here is saying that alpha is equal to 0.02. And if you pull through all that information, you can kind of do the rest of these problems. State the null and alternative hypothesis. All right, the alternative hypothesis is always the claim. And in this case, the claim is that students that have taken a statistics class are better looking than average. And I know that 48% is the average. So this thing I don't know, P, I'm claiming that that is greater than 0.48. Whereas my null hypothesis says this thing P that I don't know is equal to 0.48. And this is a right-tailed test because my alternative hypothesis has a greater than sign right here. So calculate the test statistic. The first thing to know is whether this is a Z statistic or a T statistic. It's Z in this case because we're talking about proportions. In proportions we only estimate one parameter. So we use the Z table. And what you do is you take your value of P hat, and from that you subtract P naught, and then you divide by your standard deviation. The standard deviation is P naught times 1 minus P naught divided by n, the square root of that. So, okay, we can calculate that. P hat is equal to 0.60. P naught is equal to 0.48, and so I need to divide that by the square root of 0.48 times 0.52 divided by n, which is 80. And if you do that, probably in a calculator would be the easiest way to do that, which I am doing right now. Let's see, the square root of 0.48 times 0.52, which is 1 minus 0.48, and then that divided by 80, the square root of all of that, and 0.12 divided by it. That gives me a z-score of 2.148. Alright, so that's my test statistic. Now it wants me to sketch a graph of the normal distribution showing this test statistic and the rejection region or regions. And a sentence justifying the shape of my distribution. I would say that the shape is approximately normal. And that is because n times p times 1 minus n times p naught times 1 minus p naught is greater than or equal to 10. Yeah, okay, I just want to make sure this was true. I just did it on my calculator and I found that this thing over here is 19.968. And sure enough, that's greater than or equal to 10. So my shape is approximately normal. Good, I can do this problem. So now I want to sketch a graph. I'll make something that appears to be approximately normal because of this over here. And what I want to do is show my rejection regions, or region as the case may be, and my test statistic. And so to figure out my rejection region, I go back here and I figure that alpha is 2%. And so what I need is an area over here that's 2%. That should be alpha, which is equal to 0.02. And the critical value here, the z value that will have exactly 2% of the area above it, you can get that either off your tables or using the inverse norm function. and you get something like 2.054, something to that effect. So this is my critical value, and then what I want to do is find my test statistic and figure out if it's in my critical value. My test statistic here is this 2.148, so that would be maybe somewhere over here, 2.148. The point is that this test statistic is in my rejection region. So for my conclusion, I would say because my test statistic which was z equals 2.148, falls within the rejection region. There's sufficient evidence. There is sufficient evidence to reject the null hypothesis. To reject the null hypothesis and conclude whatever we were talking about in this case, something about students that take a statistics class are better looking, whatever, and conclude that students who take a stat class are better looking. Or something to that effect. It doesn't have to be the same words. And then it says to repeat all that stuff, with the only change being that it's instead of better looking, it's different looking. Maybe what I'll do down here is I'll just highlight what would change. The first thing that would change is my alternative hypothesis would now be that P does not equal, what was it, 0.48. So it's a two-tailed test. So my null hypothesis would stay the same. My alternative would change to that. My test statistic would stay the exact same. My rejection region, let's see, changes this. Rejection region. My rejection region, there's now two of them. Rejection regions now, maybe I'll draw a picture. I need alpha to be equal to the total area of my rejection region. So if 2% is the total area, this is 1%, and this is 1%. So let's see, that would be, they'd start at 2.326. How many decimal places? Yeah, that's right. 2.326. 2.326 negative. So what would happen is I'd have a new alternative hypothesis. My rejection regions would now be as shown over here. And finally, my test statistic, which is the same, is no longer in the rejection region. So there is not sufficient evidence to reject our null hypothesis, to reject H0. So we're not saying that students who take a stat class are not better looking. We're just not saying that they are better looking. So I guess that's good enough. That's the end of this perfect problem.